the University of California at Santa Barbara, the Solidstate Lighting and Energy Center is out in front in the development of materials and technology to bring the next generation of lighting and displays.
I think the future of LED lighting is really up to the imagination of the engineers and the people that manufacture and produce it. It could go beyond just simply energy efficiency to smart lighting that's able to communicate with its users. For instance, you could have a highway in which the street lights only turn on if there's a car on it, and then they turn off after the car is passed. That would save even more than the traditional lighting sources, because you could have the lighting be controlled by the car or by the smartphone.
If you look at solid-state lighting, it's just onward and upwards. I mean, there's an inexorable push towards using lighting. It's desirable from an energy point of view.
Suji's creation of the LED light has even affected the arts. Many, if not most, movie and television sets are now using LED lights as part of their productions. By reducing both energy consumption and the hot lights used in production, Suji was given an Emmy Award for his technical innovation.
Besides LED lighting, the Solid-State Lighting Display Center is trying to imagine what the next generation of lighting would look like. So one thing we're looking at is lasers. We think actually using a laser-based light source to create white lighting could be even more efficient, particularly more cost-efficient than LED lighting, because you can get a lot of light and power out from a laser from a very small area. We also think that displays, projection displays, that's so-called a display everywhere, a very cheap display could be made with these light sources because they're extremely compact and they don't need TV screens. You could project projection displays on any surface, a wall, the ground, your car windshield, whatnot. So we're working a lot on display lighting. We're also doing a lot of work on what's called, the same material can be used for power switching. That is, we can convert power very efficiently for electrical uses. You all know when you take your computer around, you have this big block, a brick you carry with you. So one of our professors, Professor Mishra, is leading the effort in energy efficient power switching.
Gallium nitride is a material that's basically a magical material. Magical because it puts out light when it really shouldn't. It's a defective material and it's already found use. So just like it's had this magical quality in lighting, it also has a magical quality in the area that I specialize in, which is electronics. The part of electronics that gallium nitride plays into is power conversion. So you may ask, what is power conversion? Basically, power arrives in a couple of forms, and one form that you're all very familiar with is the outlet in the wall. So what the power arrives is 110 volts and in the form of AC current. But your laptop needs 19 volts of DC. So you have that adapter brick that you carry around, converting power from the form that it arrives at the outlet into the form that you use for the laptop. This happens everywhere. Your refrigerator, your washing machine, your TV, every appliance in the house needs a converted form of power. This conversion is inefficient. We waste more power in just converting power than all the power consumed by the Western United States. This is a huge problem to be solved. For that, you need what is called an ideal switch. Turns out gallium nitride, being an ideal light-emitting device, is also an ideal switch.
The Solid-State Lighting and Energy Center is not only working on the technologies of tomorrow, but also the materials needed for tomorrow's creations.
The major focus of bulk single crystal gallium nitride research is to improve on the growth rates of these crystals so we can grow them bigger much more quickly, so the cost of producing a single crystal drops dramatically. This will translate directly into the production of multiple large single crystal wafers, which then can be used for LED production, laser manufacturing, and power electronics. The hope is that these single crystal wafers will be able to produce higher efficiency, higher quality, longer lifetime devices.
SSLEC is leading in the development of the next generation of lighting with research into laser lights.
I work here at the SSLEC on making efficient laser-based white light sources. Currently, LEDs are already very efficient, but using lasers instead of LEDs, we can make more efficient. That means more optical power out for less electrical energy in, white light sources. And so we've made a demo here as a first demonstration to create a warm white light using a blue laser and a yellow phosphor instead of an LED. And as you can see, the light and the quality of the light is just as good as that made with an LED.
I'm great about the invention of blue LED, also blue laser diode, both. Because right now people are focusing on the LED lighting, because LED, it's easy to make LEDs, also in terms of the cost cheaper. But the next generation lighting, there are the high possibility to use laser diode to make next generation lighting. Same story of the LED. So initially available color of laser diode was red, because red LED available in the red laser diode available. No blue, no green. But now using my invention, blue and green laser diode available. So using a laser diode, we can make all kind of colors, including TV. I think right now huge market for LED, but next huge market for laser diode happen again. So I think I like both of invention, blue and green, blue laser diode, both.
It's only through the collaboration where we've been able to take what Shuji did before he came to UCSB, and then after he came to UCSB, we've been able to take that at a tremendous pace up in technology, both in electronics and in lighting. And it happens because of the sharing of information, the collaborative atmosphere, and also the multiple talents all working together. So it's a very exciting time in tackling a critical problem. Everybody understands that waste is not good. This is a very simple statement you can make. I think to be in a university leading the charge is, it's a once-in-a-lifetime opportunity.
From technical roadblock to world-changing breakthrough, the development of solid-state lighting has had an important and meaningful impact on all of our lives. What more significant breakthroughs and discoveries lie in our future? No one can say for sure, but it will be a journey worth watching.